Let us start the lecture. Last time हमने kinetic theory of gases के ऊपर कुछ MCQs देखे थे. आज के लेक्चर में वही हम कंटिन्यू करने वाले हैं, but the MCQs will be somewhat different. Okay, let us see the questions. Yes, the questions asked in previous exams. Okay. So first of all, the specific heat of the helium at constant volume is given to be 12.6 joule per mole Kelvin, and the specific heat of helium at constant pressure is also given there. Yes. Okay. So what we want is specific heat of the helium at constant pressure, right? तो हमको specific heat at constant pressure चाहिए, मतलब CV दिया हुआ है और हमको CP निकाल के दिखाना है, बराबर है? तो देखो कैसे निकालेंगे, ये ऑप्शंस है हमारे पास, राइट? तो हमको पता है ऑलरेडी कि CP minus CV is always equal to R, correct है? That is we have to use here, but here the CV here is given to be in joule per mole Kelvin, which is the standard unit, no problem. And R is also given to be in joule per mole Kelvin only. So we have to just add this 12.6 and 8.314 plus to get the CP value. Yes, so this will be the 21 joule per mole Kelvin approximately, which is going to be the fourth as a correct option. Getting it? See the next question here. A flask contains argon and chlorine in the ratio 2:1 by mass. The temperature of mixture is going to be 7 degrees Celsius. Okay. The ratio of average kinetic energies of two gases per molecule is. So basically देखो यहाँ पे क्या है कि argon और chlorine इन दोनों का रेशियो दिया हुआ है बाय मास, एंड द मिक्सचर का जो टेम्परेचर है वो 27 डिग्री सेल्सियस दिया हुआ है, और रेशियो ऑफ एवरेज काइनेटिक एनर्जीज ऑफ द टू गैसेस पर मॉलिक्यूल. अब ये हमको याद होना चाहिए, व्हाट इज द फॉर्मूला फॉर एवरेज काइनेटिक एनर्जी पर मॉलिक्यूल? इफ यू रिमेंबर इट इज 3/2 kT, करेक्ट है? The average kinetic energy per molecule of any gas just depends on the temperature. So we can see simply that since the temperature is going to be the same, that means the average kinetic energy per molecule must be the same for both of the gases. It doesn't depend on the mass of the molecule or size of each molecule or molar mass or anything else. Okay, so since the temperature is constant, the average kinetic energy per molecule is going to be the same for both of the gases in the sample. Remember. Chalo, next one. RMS velocity of oxygen molecules at NTP is 0.5 km per second. The RMS velocity of hydrogen molecule at NTP must be. तो देखो ये सब ऑप्शन है. सिंपल सी बात जो है वो हमको यहाँ पे C इक्वल टू रूट ऑफ 3RT अपॉन m0, ये वाला फॉर्मूला हमको यूज करना है, which tells us simply that the RMS velocity of any molecule is always inversely proportional to the square root of molar mass. Okay, इससे हमको पता चलता है कि RMS velocity जो है वो मोलर मास के साथ इनवर्सली प्रोपोर्शनल में होता है. और जबकि यहाँ पे दो चीजें दी है, एक तो ऑक्सीजन और दूसरा हाइड्रोजन, तो हम दो RMS velocities के बारे में बात कर सकते हैं. तो velocity RMS velocity of oxygen upon RMS velocity of hydrogen is equal to the root of the molar mass of hydrogen upon molar mass of oxygen, which are 2 and 32 respectively, which is going to be 2 1s are 2 16s are, so 1 upon 16 का root कितना बनता है? 1 upon 4 बनता है. And then we can just put the value of VH2, that is hydrogen का oxygen का velocity कितना दिया हुआ है? 0.5 किलोमीटर पर सेकेंड दिया हुआ है, तो वो अगर हम यहाँ पे डाल देंगे तो 4 into 0.5 जो बनता है ओनली 2 किलोमीटर पर सेकेंड. that means 2000 meter per second, which is going to be there in the option number 2 here. Getting it? Chalo, next one is how much heat energy in joules must be supplied to 14 gram of nitrogen at room temperature 40 degrees Celsius at constant pressure if molecular weight of nitrogen is 28 and R is constant. Okay, देखो यहाँ पे लिख से यहाँ पे हमको how much heat in joules must be supplied at to 14 gram of nitrogen at room temperature by 40 degree Celsius, मतलब to increase the temperature by 40 degree Celsius ऐसा रहेगा मे बी. Let us check. ये फॉर्मूला हमारे पास ऑलरेडी है. Q मतलब the amount of heat absorbed at constant pressure is always equal to number of moles N into Cp into dt. करेक्ट है? तो अगर हम ये यूज करेंगे यहाँ पे तो हमको मिलेगा. ओके, और ये एक बात यहाँ पे याद रखो कि नाइट्रोजन इज अ डायटोमिक मॉलिक्यूल, so we have to use the value of Cp as 7 by 2 R for it, and then we get this as N into 7 by 2 R into delta T, where delta T is going to be 40 degree Celsius. Okay, तो 40 degree Celsius से बढ़ाने के लिए हमको हीट कितना देना पड़ेगा वो पूछा है. और नंबर ऑफ मोल्स कैसे निकालेंगे नाइट्रोजन का? तो नंबर ऑफ मोल्स के लिए हमारे पास फॉर्मूला है N is equal to mass upon molar mass of a substance, and hence mass is going to be actually 14 gram, whereas molar mass is going to be 28 gram. So we get this 14 gram upon 28 gram, which happens to be 1 by 2. करेक्ट है? तो इसलिए यहाँ पे ये जो है n के बदले हमने क्या किया 14 upon 28 रख दिया, बराबर, जिससे हमको 1 by 2 मिलने वाला है नेक्स्ट स्टेप में. और ये 7 by 2 r as kept as it is, and delta t is replaced by this 40 here. Okay, and if we just simplify this further, then we get this 14 cancelled with this 28 leaving behind 2, and this 2 into 2 becomes 4, which cancels with 40 leaving behind 10, and 7 into 10 into r becomes 70 r, which is going to be the amount of heat energy which is to be supplied to the nitrogen, which is already there in option number 3 here. Chalo, next one. Yes, if the RMS velocity of oxygen molecule at certain temperature is 0.5 kilometer per second, then the RMS velocity of hydrogen molecule at the same temperature will be, just we have done it just now, it will be 2 kilometer per second. Yes, the root mean square velocity of molecules of gas is 1260 meter per second. Okay, the most probable speed of the molecule is, अब ये एक्चुअली चलो ठीक है, मोस्ट प्रोबेबल स्पीड का जो कंसेप्ट है वो तुमको वैसे तो रेगुलर में नहीं है, बट यू कैन जस्ट रिमेंबर दिस फॉर्मूला. नथिंग नथिंग इज so special or different about it. You can just see the formula and just remember it as it is. So here it is going to be the most probable speed जो है वो √2 RT upon m नॉट होता है, ठीक है, जबकि RMS velocity जो है वो √3 RT upon m नॉट हुआ करता है. So using this formula, just we can take the ratio and express this most probable speed in terms of RMS speed and get the answer easily, which is going to be 1029 meter per second approximately. Next one, mean free path of collision of the gas molecules varies with diameter of the molecule as. उसके लिए आपको ये फॉर्मूला याद रखना पड़ेगा. याद रखो ठीक से. The mean free path of the molecules is always given by 1 upon √2 pi n d square, where d is called as a diameter. And since diameter square is there, we can say that d raised to -2 is going to be the correct option. It is just a formula based. But don't forget here that this n is nothing but the number of molecules per unit volume, which is also called as the molecules density. Okay. Chalo, ठीक है. Next one is, if pressure of CO2 gas in a container is given by P is equal to RT upon 2V minus B minus 9 upon 4B square. Okay, then the mass of the gas in the container is, yes, so what will be the mass of the gas in the container? This is again actually out of the scope of your syllabus. Need not to solve. Forget about. Next one. Let us see. The root mean square velocity of a particle is v at pressure p. If the pressure is increased 2 times, then this RMS velocity will become, yes, this makes sense. Root mean square of the particle, root mean square velocity of the particle is v at pressure p. Okay. If pressure is increased 2 times, then its RMS velocity will become. तो प्रेशर का फॉर्मूला क्या है? It is 1/3 into m upon v into c square, where m is going to be the mass, which is going to be constant, right? And अब यहाँ पे root mean square velocity of the particle is v. Pressure is increased 2 times, but volume का क्या किया वो यहाँ पे दिया नहीं है actually. So let us assume that volume is also constant. Okay, so if volume is also constant, mass is also constant, and pressure is increased 2 times, then what we have to increase this c here by root 2 times. So RMS velocity will become, just check. Okay, at constant temperature ऐसा वहाँ पे उन्होंने mention नहीं किया है. It seems that it should be given here at constant temperature, then it will be meaningful. Okay, if it is at constant temperature, then we can understand that constant temperature पे क्या होता है? PV remains constant. Actually, it is PV. हाँ, तो PV यहाँ पे PV अगर constant रहेगा, तो उस केस में फिर क्या होगा? मोलर मास तो ऑलरेडी constant है, और तो इसके वजह से यहाँ पे RMS velocity जो है वो भी constant बन जाएगा. वैसे भी ये इक्वेशन भी अगर हमने यूज किया तभी भी वही हमको रिजल्ट मिलेगा. देखो, we can express this as PV is equal to 1/3 into mc square, correct है? And since temperature is constant, so PV remains constant and m is already constant, so we can say that this c square also remains constant, and hence the RMS velocity will remain v only in case when temperature is constant. That is to be mentioned, which was not mentioned here. At what temperature will the oxygen molecules have the same RMS velocity as the hydrogen molecules? At 300 Kelvin. Okay, तो देखो यहाँ पे लिख से, you have to use this formula, that is C is equal to root of 3RT upon m naught once again. Here it is that said that at what temperature will the oxygen molecules will have same RMS velocity as the hydrogen molecules have it at 300 Kelvin. तो मतलब ये हमको दो बार ये फॉर्मूला यूज करने पड़ेंगे, एक तो ऑक्सीजन मॉलिक्यूल के लिए और दूसरा हाइड्रोजन मॉलिक्यूल्स के लिए. ऑक्सीजन मॉलिक्यूल का जब हम यूज करेंगे ना, तो यहाँ पे 3RT टेम्परेचर के बदले ऑक्सीजन का टेम्परेचर यूज करेंगे, जो कि यहाँ पे हमको निकालना है. TO2 इज टू बी फाउंड आउट, करेक्ट है? एंड उसमें आप यहाँ पे मास भी ऑक्सीजन का ही यूज करना पड़ेगा, मोलर मास जो होता है, जो कि 32 है, हमको पता है ऑलरेडी. और इस तरफ जब हम हाइड्रोजन के बारे में बात करेंगे, तो यहाँ पे टेम्परेचर भी हाइड्रोजन का यूज करना पड़ेगा, जो कि 300 यहाँ पे दिया हुआ है. ओके, वो 300 यहाँ पे हमको डालना है नेक्स्ट स्टेप में. और मोलर मास भी हाइड्रोजन का यूज करना पड़ेगा, जो कि हमको पता है 2 होता है. ये 2 हमको डालना है और इसको 32 डालना है. So once we put all the values, we can just simplify this further as, and if it even we can just cancel out this square root by squaring both sides, and also this 3r will just get cancelled, and we'll be left with TO2 is equal to MO2 इस तरफ चला गया और TH2 ऊपर रहा और नीचे MH2 डाल दिया, और नेक्स्ट स्टेप में अगर हम ये वैल्यू सब्स्टिट्यूट करेंगे तो हमको मिलेगा MO2 के बदले 32 जो उसका मोलर मास है, और हाइड्रोजन का मोलर मास जो कि 2 है, और यहाँ पे TH2 मतलब हाइड्रोजन का टेम्परेचर जो कि यहाँ पे 300 दे रखा है, तो वो अगर हमने डाल दिया यहाँ पे तो इनको मिलेगा 16 into 300 which comes out to be 4800 Kelvin. That is going to be the temperature which is going to be there in the option number 4 here. चलो, the average velocity of ideal gas molecule is 0. एवरेज वेलोसिटी हमेशा 0 होता है. RMS वेलोसिटी जो है तो वो तो चलो हमको पता है ऑलरेडी कि इट इज प्रोपोर्शनल टू रूट टी, नो डाउट. बट RMS वेलोसिटी नहीं कि उसके बारे में पूछा ही नहीं. यहाँ पे क्या पूछा है, एवरेज वेलोसिटी के बारे में पूछा है. तो एवरेज वेलोसिटी के बारे में हम जानते हैं कि एवरेज वेलोसिटी कैन बी रिटन टू बी इक्वल टू c1 plus c2 plus c3 plus that is up to cn, and that is divided by n, where c1 c2 are all the vectors, and being all the vectors they have positive as well as negative directions, and since the opposite vectors, the vectors which are oppositely directed just get cancelled, so we can say that these vectors, the vector sum of all these velocities due to randomness will be a null vector, that is 0 bar, and that's why the magnitude of this average velocity will be 0 here. Yes, nitrogen is in equilibrium state at T equal to 421 Kelvin. Then the value of most probable speed is, again the formula, ready-made formula we have already, that is the most probable speed is always equal to root of 2RT upon m, where m is going to be the 28 gram, which is to be converted into kilogram by multiplying it by 10 raised to minus 3 here, and R is already there, that is 8.314 here, so 8.31 we can take it as approximately, and temperature is already given to be 421 Kelvin, and just work out all these calculations, so we can get the final answer as 500 meter per second. यहाँ पे ये जो 2 है तो 2 के साथ हम इसको कैंसिल भी कर सकते हैं 14, और बाकी चलो ठीक है, नॉर्मल कैलकुलेशंस हम यूज कर सकते हैं यहाँ पे, ओरल कैलकुलेशंस. ये तो बहुत इजी है, इट इज बेस्ट जस्ट फॉर्मूला बेस्ड. 4 मॉलिक्यूल्स का करंट वेलोसिटी दिया हुआ है 1 किलोमीटर पर सेकेंड, 3 किलोमीटर पर सेकेंड, 5 किलोमीटर पर सेकेंड एंड 7 किलोमीटर पर सेकेंड. So we have to find out the difference between average velocity and RMS velocity. What do you mean by the average velocity? Just the sum of all the velocities divided by number of molecules, that is 16 by 4, which happens to be 4 meter per second here. And what do you mean by the RMS velocity here? It is the sum of square of all the velocities divided by number of molecules, and that is root of that. So we get this as 1 square, 2, 3 square, 5 square, 7 square, which happens to be 84 actually, which is divided by 4 comes out to be root of 21, and root of 21 is going to be root 4.583, and if we just take the difference, then we can get this as 0.583, and everything is given in kilometer per second, so answer will also be in kilometer per second only, which is going to be there in the option number 3 here. Let us see the next one. 10 ml of ideal monatomic gas at 10 degrees Celsius is mixed with 20 ml of another monoatomic gas at 20 degrees Celsius. Then the temperature of mixture is, ये मैंने स्टार्टिंग में जब थ्योरी एक्सप्लेन किया था तभी बताया था कि अगर दो सिमिलर टाइप के गैसेस अगर मिक्स किए जाते हैं तो उस केस में हमको मिक्सचर का टेम्परेचर कौन से फॉर्मूला से निकालना है, उसके लिए ये फॉर्मूला हमने डिराइव किया था, याद होगा आपको. तो अगर हम ये यूज करेंगे यहाँ पे तो हमको मिलेगा, देखो नंबर ऑफ मोल्स हमको निकालने हैं. N1 मतलब क्या है यहाँ पे, नंबर ऑफ मोल्स, which is okay. So since number of moles is proportional to the volume, we can just use volume instead of number of moles here. तो यहाँ पे हमने क्या किया, N1 के बदले उसका वॉल्यूम यूज किया, दैट इज 10 ml, और दूसरा जो है उसका 20 ml वॉल्यूम हमने यूज किया N2 के बदले, और यहाँ नीचे भी वॉल्यूम ही यूज किया क्योंकि नंबर ऑफ मोल्स इज प्रोपोर्शनल टू वॉल्यूम. So it's okay if we use this volume instead of number of moles here, and that's why we have used this 10 20 10 20 here. बाकी temperatures तो हमको पता है already. 10 डिग्री सेल्सियस जो है वो कन्वर्ट किया 273 ऐड करके केल्विन में, और इसको भी 20 को भी कन्वर्ट किया केल्विन के अंदर, ये 273 है ना. ओके, तो इससे जो कैलकुलेशंस हम करेंगे तो उससे हमको ये आंसर मिलेगा, that is 10 into 270, this will actually be 10 into 283, correct है, plus here it will be 20 into 293, right, that is to be whole divided by 30. Okay, so if we just solve this here, so this will actually be 2830 plus here it will be 6 and 58 and 0, that is to be divided by 30 as it is. So if we add this together, then we get this 8690, which has to be divided by 30, so that we get this 289.66 Kelvin as a final, which is going to be there in this. अच्छा, इसमें से भी इसको भी हमको डिग्री सेल्सियस में कन्वर्ट करना है, तो उसके लिए इसमें से भी 273 माइनस कर दो, जिससे हमको मिलेगा सिंपली 15 डिग्री सेल्सियस के आसपास, which is actually going to be yes 16.6 degree Celsius as a final. Yes, the temperature at which the mean kinetic energy of molecules of gas is 1/3 the mean kinetic energy of molecules at 180 degree Celsius is. तो मतलब हमको ऐसा एक टेम्परेचर निकालना है जहां पे काइनेटिक एनर्जी जो है वो 180 डिग्री सेल्सियस पे जितना होता है उसके 1/3 बन जाए. देखो सीधी बात है कि काइनेटिक एनर्जी पर मॉलिक्यूल इज प्रोपोर्शनल टू द टेम्परेचर, करेक्ट है. उसके लिए फॉर्मूला क्या है हमारे पास, 3/2 kT है, बराबर. तो अभी हमको दो बातें दी हुई है, एक तो E1 जो कि T1 upon T2, we can say it will be actually equal to T1 upon T2, करेक्ट है, जिसमें E1 और E2 के बीच में रिलेशनशिप दिया हुआ है. क्या दिया हुआ है, that we have to find out the temperature T2 here at which the kinetic energy is 1/3 of kinetic energy at 180 degree Celsius. मतलब E2 is given to be 1/3 of E1, correct है, and T1 is given to be 180 degree Celsius, which can be converted into Kelvin by adding 273 in it. तो 180 plus 273 अगर करेंगे तो कितना बनेगा, तो हमको T1 मिलेगा 453, correct है. So this is 453 Kelvin, and if we replace it here then we get this. अच्छा, E2 के बदले E1/3 E1 भी डालना है, मतलब ये क्या होता है, E1 is going to be 3 times of E2, and if we replace this E1 by 3 times of E2, then we get this 3E2 upon E2, which is going to be T1, which is 453 upon T2, and just solve this by cross multiplication. E2 cancel, and we are left with T2 simply equal to 453 upon 3, which is actually going to be 151, correct है. sorry 151 नहीं, हाँ 151, correct. So 151, but that is in Kelvin, right? If we want it in degree Celsius, then just subtract 273 from this 151 here. So देखो 151 minus 273, how much it comes out to be. In short, we have to subtract 151 from 273, which actually happens to be 122 minus 122, बराबर है. So here it is minus 122 will be the correct option. Next, a closed vessel contains 8 gram of oxygen and 7 gram of nitrogen. The total pressure is 10 atmosphere at a given temperature. If now oxygen is absorbed by introducing a suitable absorbent, then the pressure of remaining gas in atmosphere will be. These are the options. See here, एक closed vessel है जिसके अंदर 8 ग्राम ऑक्सीजन, मतलब कितना नंबर ऑफ मोल्स हो गया उसका? What is the number of moles of oxygen? It is 8 upon 32, which is actually going to be 1 by 4. मतलब ठीक है, 1 by 4 रखो वैसे ही. And what about this N2, number of moles of nitrogen, which is going to be 7 upon 28. That is 1 by 4 once again. Okay, तो दोनों के 1 by 4 number of moles है. तो total number of moles कितने हैं? Which is going to be N1 plus N2, which is 1 by 4 plus 1 by 4, which happens to be 1 by 2 actually. Correct है? तो ये number of moles हो गया total. And pressure is going to be 10 atmosphere at a given temperature. Yes. So if we use this PV is equal to nRT on that, then we get this PV is equal to nRT. It gives P के बदले आएगा 10 into V as it is equal to N के बदले आएगा 1 by 2 into RT as it is. And if we just take this 2 in that side, then we can get that 20V is going to be equal to RT. Okay, this is equation number 1. Just record it as it is. Okay, but now what happens in the second situation is oxygen is absorbed. That means number of moles of oxygen get lost and only this nitrogen will be left in the whole container. Volume of container is going to be the same. Okay, but the number of moles has been decreased. So if we use this PV is equal to nRT once again, तो यहाँ पे P dash V is equal to new number of moles will be N dash into R into T. Temperature is also same, हाँ? तो अगर हम ये यूज करेंगे यहाँ पे तो P dash के बदले जो आएगा वो हमको निकालना है. We don't know how much it is, but N dash के बदले क्या आएगा? Only nitrogen is left. So nitrogen का कितना contribution था उसमें? 1/4 number of moles उसके थे. तो इसलिए यहाँ पे N dash के बदले क्या आएगा? 1/4, because now in this case the whole volume of this container is filled with nitrogen only, and that is multiplied by RT as it is. So that here we can say if we keep this, put this value of RT as 20V here, then we can get this simplified as P dash V is equal to 1/4 of 20V. So 4 ones are 4 5s are, and we are left with P dash V is equal to 5V. So that VV gets cancelled and we are left with P dash equal to 5 atmosphere. Correct? Hai? So this 5 atmosphere will be actually the correct option. That means the pressure will just get halved because number of moles has been halved. Okay, number of moles के साथ pressure सीधा direct proportion में होता है, और जबकि यहाँ पे number of moles आधा हो गया तो इसकी वजह से यहाँ पे प्रेशर भी आधा हो जाएगा, 10 के बदले 5 हो जाएगा. बिल्कुल, that is the from top view. Yes, simple behavior. Okay, ये तो चलो ठीक है, ये तुमको पता होना चाहिए. This is the van der Waals gas equation. The kinetic energy of 1 gram molecule of gas at normal temperature and pressure is. Okay, 1 gram molecule मतलब क्या? 1 mole. बराबर है ना? तो what is the formula for kinetic energy per mole? It's going to be 3 by 2 kT. 3 by 2 RT. बराबर? So if we put all the values here, we can get the answer quickly. Which one of the following is not an assumption in kinetic theory of gases? The volume occupied by molecules of gas is negligible. The force of attraction between the molecules is negligible. The collision between the molecules are elastic. All molecules have same speed. This is not the assumption made by the kinetic theory of gases. All molecules are not of the same speed. Okay, that's why we find out the RMS velocity, no? Next is a closed compartment containing a gas is moving with some acceleration in the horizontal direction, neglect the effect of gravity, then the pressure in that compartment is. Yes, it's going to be. अभी देखो क्या होगा कि अगर सपोज ये कंपार्टमेंट है और अगर ये एक डायरेक्शन में मूव कर रहा है, इस डायरेक्शन में अगर वो मूव कर रहा है, तो क्या होगा कि द मॉलिक्यूल्स विल have experience a pseudo force, and because of that they will tend to collide on this surface, back surface, more rigorously than here. ठीक है, इस सरफेस के साथ उनके जो कोलिजन है वो थोड़ा लाइट होंगे क्योंकि ऑलरेडी ये कंटेनर इस डायरेक्शन में मूव कर रहा है, बराबर। तो उसकी वजह से क्या होगा कि उनका जो मास भले कितना छोटा होने दो, बट दैट all the molecules will experience a pseudo force in the down backward direction, and because of that pseudo force they will exert additional pressure on this backside container. So that's why the front side का जो surface है that will experience a lower pressure here, and here the pressure will be higher. Okay, the mean free path equation itself tells us that it is inversely proportional to the number density. Cv for O2 is 5 by 2 R. Okay, with increase in the temperature it becomes 7 by 2 R due to, yes, ये देखो यहाँ पे ये conceptual question है, जो मोलर स्पेसिफिक हीट एट कांस्टेंट प्रेशर ऑक्सीजन के लिए कितना होता है, 5 by 2 R के बराबर होता है, क्योंकि ऑक्सीजन जो है वो डायटोमिक तो है but it is not vibrating at that temperature. Okay, but with the increase in the temperature, when the temperature increases beyond almost 500 Kelvin and so on like that, the Cv of value, मतलब जो specific molar specific of the gas at constant volume becomes 7 by 2 for oxygen only. So even if it is diatomic, but still its Cv value becomes 7 by 2, which is for the vibrating diatomic molecule, and that is because, so मतलब conceptually यही है, ये जो 5 by 2 R से ये 7 by 2 R जो बनता है Cv का वैल्यू, वो वाइब्रेशन की वजह से ही बनता है, क्योंकि ऑलरेडी 5 by 2 के अंदर क्या क्या इंक्लूडेड है, 5 जो डिग्रीज ऑफ फ्रीडम होते हैं उसके अंदर 3 ट्रांसलेशनल और 2 रोटेशनल ऑलरेडी इंक्लूडेड है, बट जब वो 7 बनता है तो 7 कभी बनेगा जब 3 ट्रांसलेशनल प्लस 2 रोटेशनल और प्लस 2 वाइब्रेशनल भी उसमें ऐड हो जाए, तो ये वाइब्रेशनल की वजह से ही ये 7 बनता है इंस्टेड ऑफ 5, एंड दैट्स व्हाई द आंसर विल बी द वाइब्रेशनल. ओके, average forget about this. Yes, what is the ratio of RMS speed of oxygen to hydrogen? RMS speed of oxygen and hydrogen का रेशियो होगा उनके मोलर मास के रेशियो का उल्टा, इनवर्स. ओके, तो मोलर मास का रेशियो का उल्टा, मतलब यहाँ पे ऑक्सीजन है तो ऑक्सीजन का मोलर मास इधर नीचे आएगा, और हाइड्रोजन नीचे है तो उसका मोलर मास ऊपर हमको लेना पड़ेगा, और रूट तो लाना ही है क्योंकि V is inversely proportional to root T and root M, sorry, and that's why we can get this as root of 2 by 32, which happens to be 1 by 4 actually. At which temperature RMS speed of our air molecules is double of that of NTP. तो RMS speed जो है वो हमको डबल करना है, तो देखो यहाँ पे V is proportional to root T, and इसका मतलब ये होता है कि T is proportional to VRMS का स्क्वायर, बोल सकते हैं ऐसा, and since VRMS has to be doubled, RMS speed को हमको क्या करना है, डबल करना है, तो when VRMS will get doubled, what will happen to this T here? It will become 4 times. That means we have to make the temperature 4 times of that of NTP. तो अगर हम 4 times of NTP करेंगे तो NTP मतलब 273, उसका 4 times बनता है 1092 Kelvin, but that is in Kelvin. If you want it in degree Celsius, just subtract 273 from it and we get this 819 degrees Celsius as a final answer. Okay. To which temperature should the hydrogen at 327 degrees Celsius be cooled at constant pressure so that the RMS velocity of its molecules becomes half of its previous value. Okay. तो हमको अभी RMS velocity जो है वो हमको half करना है. Again we can say that this RMS velocity is proportional to root of t, correct? So we can say that this t is proportional to root of c square, right? c square के साथ वो डिपेंड करता है. अगर c को हमको आधा करना है तो t को क्या करना पड़ेगा? 1/4 करना पड़ेगा. So t dash has to be 1/4 of t, and t is already 327 degrees Celsius. See here, which has to be converted into Kelvin. So what must be t dash then? 1/4 of t, where t is going to be 327 plus 273, which becomes 500 actually. So here it is 500. And if we just divide this 500 by 4, it comes out to be 125. But this 125 is again in Kelvin. If you want it in Celsius, तो कितना आएगा? T dash will actually be 125 minus 273, which happens to be 152. करेक्ट है? Yes. नहीं, 148. Sorry, 148 it will be. Minus 148 degrees Celsius, but there is no option like that. So we can select this, none of this as the correct option. So 150 कैसे आया? अच्छा, ये 600 बनता है. करेक्ट राइट. 500 नहीं, 600, सॉरी. Okay, so it will be 150 Kelvin, and if we subtract 273 from it, then it will become minus 123 degrees Celsius, which is already there in the option number 1. Where is it? वो तो 819 degrees Celsius है. Still it is none of these only. A sealed container with negligible coefficient of volumetric expansion contains helium when it is heated from 300 Kelvin to 600 Kelvin. Then the average kinetic energy of helium atoms becomes double. Because see, the average kinetic energy of helium atoms is going to be equal to 3/2 kT, correct? So since temperature has been doubled, the average kinetic energy will also get doubled. If at the same temperature, the pressure, the densities of two diatomic gases are D1 and D2 respectively, then the ratio of mean kinetic energy per molecule of the gas will be. Okay. What is the formula for mean kinetic energy per molecule? It is 3/2 into kT. Correct? It depends only on the temperature, right? And it's already given that same temperature. Since it is the same temperature, so we can conclude that the ratio of kinetic energy per molecules will be 1:1 only. So option will be 1. According to the Maxwell's law of distribution, the velocities of molecules, the most probable velocity is, देखो ये फॉर्मूला से ही हम कंक्लूड कर सकते हैं. आरएमएस वेलोसिटी का फॉर्मूला है √3RT/m, और दूसरा मोस्ट प्रोबेबल वेलोसिटी का फॉर्मूला है √2RT/m. So it means that RMS velocity is going to be greater than most probable velocity. So most probable velocity has to be less than RMS velocity. So we have the option number 4 correct here. See here, the 10 degrees Celsius, at 10 degrees Celsius, the value of density of fixed mass of an ideal gas divided by its pressure is x, then at 110 degrees Celsius, this ratio will be, देखो, what we are talking about is the value of density of fixed mass of the gas divided by its pressure. मतलब देखो rho by p, इस रेशियो के बारे में हमारी बात चल रही है. So what this ratio depends upon? See, we have the formula p is equal to 1 by 3 into rho into c square. Correct है? And this c is actually going to be root of 3 RT upon m. So if we replace it by that, then we get this as 1 by 3 rho into c के बदले आएगा 3 RT upon m naught, where m naught is going to be the molar mass of that substance. So if we just cancel these 3 out, then and then just take this p in the denominator here. So what will be this rho by p ratio here? So rho by p ratio comes out to be m naught upon RT, correct है? So देखो m naught upon RT, this ratio is the rho upon p here. That means rho upon p, ये जो ratio है वो ratio actually टेम्परेचर के ऊपर इनवर्सली डिपेंड करता है, करेक्ट है? तो इसका मतलब ये होगा कि रो बाय पी रेशियो को अगर हम बोल देंगे सपोज आर, ओके, तो रेशियो इन द फर्स्ट केस आर वन इज गोइंग टू बी, so R1 upon R2 is actually going to be equal to T2 upon T1, right? And R1 is given here, which is X here. तो R1 के बदले यहाँ पे X आएगा, R2 हमको निकालना है, और T2 T1 कितना दिया हुआ है यहाँ पे 10 डिग्री सेल्सियस दिया हुआ है, 10 डिग्री सेल्सियस, which can be converted into Kelvin by adding 273 in it, so as to get this as 283, and that is to be divided by T2, sorry T1, सॉरी T1 जो है वो हमको रखना होगा डिनोमिनेटर में इधर. यस, सो इट विल बी 283 kept here, एंड T2 कितना है 110 डिग्री सेल्सियस है, तो इसलिए T2 को अगर 110 डिग्री सेल्सियस को अगर 273 ऐड करो तो वो केल्विन में आ जाएगा, और वो बनेगा 383 here, and then we'll be able to get this R2 from this equation here. So R2 will actually be equal to 283 इधर और 383 नीचे, तो it will be 283 upon 383 into x, which is already there in option number 4. Okay. The speed of sound in hydrogen at NTP is 1270 meter per second. Then the speed of mixture of hydrogen and oxygen in the ratio 4:1 by volume will be. ठीक है, RMS velocity जो है तो वो हाइड्रोजन का दिया हुआ है 1270 मीटर पर सेकेंड, and we want to find out the RMS speed of mixture of hydrogen and oxygen in the ratio 4:1 by volume. देखो RMS स्पीड का फॉर्मूला क्या है हमारे पास, C is equal to root of 3RT upon m naught, where m naught is going to be the molar mass, बराबर? ठीक है, so when the temperature is constant, the RMS velocity will be inversely proportional to the square root of molar mass here. तो यहाँ पे C is given to be 1270, which is going to be root of 3RT upon m naught, where m naught is nothing but molar mass of hydrogen, which is going to be 2 here. Okay, give this equation number 1. But now, if suppose hydrogen and oxygen are mixed in the ratio 4:1 by volume, then what will be the number of moles first of all? अरे क्वेश्चन में करेक्शन है एक्चुअली. They are asking the speed of sound in a mixture. Okay. Speed of sound in a gas is, we know that it is actually root of r gamma RT upon m. Okay, chalo, there is some correction. We can just forget about it. Okay, so let us see the next आगे की जो questions है तो वो next lecture में देखेंगे. Okay, let us stop here. Thank you all of you.